Okay, so I want to go over a few things that we did in class today, just in case some of you still have some doubts. So one of the things we did today was refresh our changing improper to mixed and mixed to improper. Okay, so let's take an example here. Let's take, I don't know, mixed number. Okay, don't know what that was, but let's try again. So 3 and 2/5, and we want to change this to a improper fraction. Okay, so I'm going to do this differently than I did in class. I'm going to take something like this: 1, 2, 3, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. These are my three whole numbers here. Okay, chocolate bar cut into fifths. Okay, so if I eat the whole thing, obviously it's one full chocolate bar. Another chocolate bar cut into fifths, and I eat that one, and another chocolate bar cut into fifths, and I eat that one. And then we have another chocolate bar cut into fifths, but I'm not eating the whole thing. Instead, I eat two. So this is really the long way of doing this, of changing a mixed to an improper. So I know that each piece over here is 1/5. This is also 1/5. This is also 1/5, and so on and so on. So I'm going to count my fifths. I got 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, 10/5, 11/5, 12/5, 13/5, 14/5, 15/5, 16/5, 17/5. So that, ladies and gentlemen, is the same thing as saying 17/5. If you want to do it the way we did in class, the shortcut, you go like this, and you're going to multiply 5 and 3, which is 15, and then add the product to the numerator over here. It gives you 17, and the denominator, we leave it the same. But I like to do it with pictures so you can get an idea of what that really looks like. Okay, so I'm going to do one more. I'm not going to use big numbers. So 2 and 3/4. Using pictures, which is what I asked you to do in class today. Here is my 1, 2, and we're going to cut it in fourth because my denominator here is fourth. Okay, so here's chocolate bar again. In this case, they're all cut into fourth. So 1/4, 2/4, 3/4, 4/4. That's one full chocolate bar that I eat. Another fourth, 2/4, 3/4, 4/4. Two full chocolate bars that I eat. Okay, and then of another one, I eat only 3 pieces instead of the whole thing. So here's my 2 and 3/4. Now I want to change this to an improper fraction. I know that each piece over here, let's take this guy right here because I have room, is 1/4. This is also 1/4, and that's also 1/4, and that's also 1/4. So let's add the fourth: 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4. So that means that I have 11 of these 1/4 pieces combined together. If that works, let's see, 4 times 2 is 8, plus 3 is 11, and that's how I get the improper fraction 11/4. Okay, let's go backwards. Let's see, 9 over, let's make it an easy one, 9/2. And it's an improper fraction, so I want to change this to a mixed number. So what you're going to do is you're going to divide the numerator by the denominator, giving you 9 divided by 2 is 4. You have a remainder of 1, and the numerator stays the same. I'll do that on the side here so you can see. 9 divided by 2. 2 goes into 9 4 times. Okay, which is 8. That becomes my whole number. And if you subtract 9 minus 8, you get 1. You're not going to continue this. And your remainder is right here. So 9 over 2 is the same thing as 4 and a half. Let's use pictures again. Okay. So here is, and denominator right here tells us what we want to cut. So here's a chocolate bar. That's 1/2. That's another half, or 2 over 2. But we got to keep going. So another chocolate bar, 3 over 2, 4 over 2. Another chocolate bar cut into halves. So 5 over 2. This is 6 over 2. Not enough yet. So we're going to take another chocolate bar, cut that in half. I'll eat that one, so it makes it 7 over 2. Eat that piece, makes it 8 over 2. And I need another chocolate bar, but I'm not going to eat the whole thing. I'm going to eat that half. So 9 over 2, which means that I have this half piece 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. As you can tell, this is 1 full chocolate bar, another one, 2 chocolate bars, 3 full chocolate bars, 4, and a half of the next one. And that's how I get 4 and a half. Okay? I know the division is easy, but I want you to visually see what exactly that means. Let's do another one. Let's do 11 over, okay, that's not going to work like that. Let's do 11, why is it so slow? Okay. Alright, so let's try 11 over, alright, let's try 11 5, something easy. Okay, so division, 5 goes into 11 2 times, giving you 10. And you have 1 left over. So quotient over here becomes your whole number. The 1 at the bottom is your numerator, and your denominator 5 stays the same. Let's see how that works. So you want something that's cut into fifths. 1, 2, 3, 4, 5. Okay, so that's 1/5, 2/5, 3/5, 4/5, 5/5. Not enough yet. 6/5, 7/5, 8/5, 9/5, 10/5, and you want 1, 2, 3, 4. There you go. So each of these is 1/5, and if you count with me, you have 1/5 over here, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, 10/5, 11/5, and that's the number right here. Or if you look at this, that's 1 full chocolate bar that I ate, another chocolate bar that I ate, make it 2 full chocolate bars, and 1/5 of that other one. Okay, that's how you get 2/5. Okay. Another thing we talked about today was something. Oops. Okay. I told you about something called real numbers. Everything, all numbers belong to this family right here, the family of real numbers. But like with any family, there's divisions. So the real numbers divide into 2 categories: rational and irrational. We're not going to worry too much about our irrational numbers right now, okay? But we're going to concentrate on the rational. So on the rational side of the family, there are categories. We learned that the first category was your natural numbers. Okay, remember the caveman story that I made up? Well, natural. Simple numbers. 1, 2, 3, 4, 5. Simple, nice, whole numbers. As time evolved, somebody said, well, let's add the representation for nothing. 0. 1, 2, 3, etc. Okay, so a 1 is a natural and a whole number, but a 0 does not belong to the natural set. 0 just belongs to the whole number set. After whole, we created something called integers. Integers are what we had before, the 0, the 1, so the whole numbers, and they're opposites. So if there's a 1, opposite 1 is negative 1. Opposite of 2 is negative 2. Opposite of 3 is negative 3, and so forth and so forth. After integers, somebody said we need more about partial numbers, fractions, halves, fourths, etc. We also need decimals. Okay? Remember, decimals and fractions. Okay? We can represent numbers as fractions and as decimals. Decimals, what did I say? They're terminating. Decimals that end. Okay? Like, I don't know, 2.4. That's a decimal that ends, doesn't continue forever. And the other decimal that we care for is the repeating decimals. Repeating decimal has a number or group of numbers that repeats itself. So let's take one, for example, 1.555, and that goes on forever and ever. So any number that is in this area right here is a rational number. Okay? If it's a repeating decimal, it's a terminating decimal. If it's a fraction. If it's an integer, a whole number, any of these categories, they are rational numbers. Okay? What's next? Absolute value. Okay. Absolute value. Alright, so, absolute value. Absolute value literally means how far is a number away from 0. Okay? So, anytime you see a number like this, between two vertical bars up and down, the question is, how far is this particular number away from this 0? So we're finding its absolute value. Remember, distance can't be negative. So absolute value of -2 means you are here at this current location. How many spaces do you need to get? You need to move to get to 0. This case is 2. Another number that has an absolute value of 2. Let's take +2. If you're here and you need to go to 0, you would need to move 1, 2 spaces. So the absolute value of -2 is 2, and the absolute value of +2 is also 2. They're both 2 spaces away from 0, which also makes them opposites. So -2 and 2 are also called opposites. Why? Because they are the same amount of spaces away from 0. Okay? Let's see. The page turns. There we go. So absolute value. So if we have something like this, absolute value of negative 257. So imagine yourself on a number line, and you're right here at negative 257, and you have to go all the way to 0. How many spaces do you need to move to get there? All you need to get there, 257 spaces. It takes 257 spaces away from 0. Okay? And that works for positive numbers, so let's say 389. In this case, 0 is here, and 389 is somewhere over here. How far are you away from 0? You're 389 spaces away from 0. Okay? We talked about opposites as well. Opposite. two numbers are opposite, 7. Oops. 7 and -7 are opposites of each other. There's a reason. I know everybody knows they're opposites, but the reason they're opposites is because 7 is over here, -7 is over here, and this distance right here, and this distance right here is the same. Same distance away from 0. Okay, they're both. It takes them 7 steps to get to 0, and this guy takes 7 steps to get to 0. So they're equally just as far away from 0. Okay. Is that it for today? I think so. Okay. Hopefully that answers some of your doubts. That's it.